This is Ms. Steele's Precalculus, Section 9.9. We're going to be dealing with systems of linear inequalities. We're going to be asked to graph the solution of system of inequalities. The solution to these systems is just where the shaded regions overlap. So looking at an example, example number 1, we have y is greater than x squared minus 3. Since it's in the form y equals x squared minus 3, we know this will be a parabola. So we can create an xy table using the points -2, -1, and 0. When x is -2, -2 squared is 4, 4 minus 3 is just 1. So when x is -2, we have a y value of 1. When x is -1, -1 squared is 1, 1 minus 3 is -2. So at -1, we have a y value of -2. And then when x is 0, 0 squared is 0, 0 minus 3 is -3. So our vertex is at 0, -3. Since we don't have any shifts, our axis of, or we don't have any horizontal shifts, our axis of symmetry is going to be at the line y equals 0. So we can go ahead and reflect our points across that line. Since it's y is greater than and not greater than or equal to, we know that we're going to have a dotted line. Thinking of the region that we will need to shade in the parabola, we can just plug in a point that's not located on the parabola. The origin, 0, 0 is a great one to choose just because it's easy to calculate. So 0 is greater than 0 minus 3. So is 0 greater than -3? Sure enough it is, so we would be shading inside the parabola. Looking at the next inequality, we have x plus 2y is less than or equal to 6. Since this is just a linear or it's in the form of a linear equation, we can go ahead and solve for y. So let's subtract x on both sides. We have 2y is less than or equal to -x plus 6. To solve for y, let's just divide by 2. And then y is less than or equal to -1/2 x plus 3. So we can go ahead and graph this inequality. So our y-intercept is at 3, and then we have a slope of -1/2, so down 1, right 2, or up 1, left 2. And since this is less than or equal to, it's going to be a solid line. Now thinking of where to shade for this, let's plug in something that is not on that line. Again, the origin is a great coordinate to choose. So 0 plus 2 times 0 is less than or equal to 6. So we can ask ourselves, 0 less than or equal to 6? Sure enough it is, so we would be shading below that diagonal line. So seeing where the two graphs overlap, and the two inequalities overlap, would be within this shaded region. The solution to this system of inequalities is that shaded purple region. Looking at our next example, example number 2, we have x squared plus y squared is less than or equal to 16. If you can think back to the conic section in Algebra 2, this is a circle centered at the origin, and since 16 can be rewritten as 4 squared, it's a circle centered at the origin with a radius of 4. So we can go ahead and plot our radius points. And since it's less than, we know it needs to be a dotted line. Thinking of where to shade in this circle, the origin is not located on the radius or the circumference of the circle, so we can use the origin as a ordered pair to test. So 0 plus 0 is less than 16. Certainly 0 is less than 16, so we would be shading inside the circle. So now for the second inequality, we have x squared plus 2y is greater than or equal to 1. So let's go ahead and solve for y. When we subtract x squared on both sides, we're left with 2y is greater than or equal to negative x squared plus 1. And then dividing by 2, we're left with y is greater than or equal to negative 1/2 x squared plus 1/2. So let's go ahead and make a table so we know what points to plot. At x equals negative 3, we have a y value of negative 4. At x equals negative 2, we have a y value of negative 1.5. When x is negative 1, we have a y value of 0. And at x equals 0, we have a y value of 0.5. So going in and plotting these points, at negative 3, we have a y value of negative 4, negative 2, negative 1.5, negative 1, 0, and then 0, 1.5, or I'm sorry, 0.5. And again, since this, the vertex is 0.5, so we can go ahead and plot the points in, reflecting off the axis of symmetry. And since we have a greater than or equal to symbol, we know that this will be a solid line. So it will look something like this. Since the ordered pair 0, 0 is not lying on the parabola, we can go ahead and check 0, 0 as a point. So 0 plus 0 is greater than or equal to 1. Certainly 0 is not greater than or equal to 1. So we know that when we shade, we will have to shade above the parabola, but still within the circle. So the shaded region inside the circle, but still above the parabola, is our solution to the inequalities, the system of inequalities. And now finally, for our last example, example number 3, our first inequality is x is greater than or equal to 0. This is the vertical line along the x-axis, and since it's x is greater than or equal to, we know it will be a solid line. In this case, we cannot check the ordered pair 0, 0, but instead we can check the point maybe 1, 0. So when x is 1, is 1 greater than or equal to 0? Sure enough, so we know that we will need to shade to the right. The second inequality is y is greater than or equal to 0. Since it's greater than or equal to, that will be the solid line along the y-axis. And so again, we cannot check the ordered pair 0, 0, but instead let's check the point maybe 0, 1. That's when y is 1. Certainly 1 is greater than or equal to 0, so we will need to shade up. So currently, the only quadrant we would be shading is the first quadrant. So now looking at the next inequality, we have y is less than 6. So we need to go up to where y would be 6. And since it's less than, we will be drawing a dotted line. In this case, we can check the point 0, 0. So is 0 less than 6? Yes, it is. So we will be shading downward from that horizontal line. And now lastly, we have 2x plus y is less than or equal to 8. We can go ahead and solve for y. So let's subtract 2x. So we have y is less than or equal to negative 2x plus 8. So since our y-intercept is up at 8, then we have a slope of negative 2 over 1. So down to right 1, down to right 1, down to right 1, down to right 1. And since it's a less than or equal to sign, we know that this will be a solid line. So deciding what to shade in, certainly 0, 0 is not on that green line, so we can go ahead and check 0, 0 into the original equation. So 0 plus 0 is less than or equal to 8. Certainly 0 is less than or equal to 8, so we know that we will be shading towards the origin. So we know that we will be shading up from that red line. We'll be shading to the right from the from the blue line. We're shading downward from that purple horizontal line, and we're shading towards the origin from the green line. With all of these arrows drawn, it's kind of easy to see that this almost triangular shaped region is the solution to our system of inequalities.